Hello, I'm Dr. Jenny Sue Flanagan of Just Simple Science. You know, I have always believed that teaching science doesn't have to be hard or expensive. There are so many inexpensive things that we can use to get students excited about learning, curious, and really asking great questions like scientists do in the real world. Fall is one of my favorite times because you know what? We get to use these little guys to get our students thinking and working like real scientists. I am excited to share with you today just an idea how you can use pumpkins in your science classroom to get students designing their own testable question. Now, I know you've probably had your students count seeds already, and you've already had them do some work with pumpkins, but you're going to want to go back to the grocery store or to your farms and get some of those discounted pumpkins because we've got lots that we can do with our pumpkins, even into Thanksgiving. So if you're ready to learn some more, just come on and let's get into science. This lesson has been designed using the 5E learning model. Each section of this lesson can be done in 20 minutes or less. You're going to want to get the following materials. Be sure to pick up 2 different pumpkins. You want to find 2 pumpkins that have 2 very different number of lines on them. Because in this lesson, students are going to be looking at the features that can indicate how long a pumpkin has been on the vines. And they're going to develop a testable question that ultimately gets at, if we change the number of lines, does that impact the number of seeds that we might find in the pumpkin? So you want to find pumpkins that are different colors and have different numbers of lines. You're also going to want to have measuring tools. You're going to want to have a measuring tape that's flexible. Rulers are not useful in this little activity, this lesson plan, because you're going to want to be able to measure the circumference around the pumpkin. You also need to have a scale that you can find the weight and mass of your pumpkin. Bathroom scales work great. You'll also, if you're going to have the students actually count the number of seeds again, if you haven't done that, you're going to need newspaper or something to cover the tables because you don't want it's going to get messy when they start pulling those seeds out. You might also want to have some magnifying lenses on hand. So the first thing you're going to do, and this is the first section of the 5E model, and I've actually taken the first 2 E's, engage and explore, and I've put them together. You're going to have your students make quantitative observations of the pumpkins. And this is, I want you to think about numbers. So oftentimes when we think of observations, we just have students write down words to describe what they're seeing, what they're feeling, what they're hearing. We need to actually get some hard numbers with our pumpkins. So we want to find the mass and the weight. Now here on Earth, mass and weight is the same thing. If we were to take our pumpkins to Pluto, we would find that their weight would change, but their overall mass would stay the same. Remember, mass is the amount of matter or the stuff that makes up an object, and that's not as easily changed as weight is. And weight is the direct pull, it's the measurement that tells us the pull of gravity on the objects here on Earth. Circumference, we're going to go around the pumpkin to find out how, what is the size of the pumpkin around. And then we want to count the number of lines. And I'll tell you specifically how you do that. But you're going to have students get some quantitative observations of their pumpkins. You're also going to want to make qualitative observations. These are the observations that we use with our senses. They are great observations to collect, but we know that quantitative are far more accurate, and scientists typically rely on quantitative observations more than they do qualitative. But qualitative is perfect for this activity. The key to qualitative observations is we want our students generating lots of describing words. What colors, what shape, what size. So you want to link them to the physical properties of the object. So again, like I said, what color, what size, what shape, what's the texture of the outside, the skin of the pumpkin, what's the texture of where the stem connected to the pumpkin. So you want to post these. These are great words that you can use in additional center activities. So if you're doing this in a 3rd grade or 4th grade classroom, think about putting the describing words that students generate from this first portion of the activity and giving them a thesaurus and having them look for synonyms and antonyms of the words that they generated. Here are my two pumpkins that we use with our students. And as you can see, the pumpkin on the left that has the little sticker there is clearly much taller than the pumpkin on the right. We can also see, and my student said that pumpkin A, or the pumpkin on the left-hand side, was a darker orange than the pumpkin on the right-hand side. It was really light orange. And you can see that one had a stem and one didn't have a stem. The other piece that we looked at is we also looked at the number of lines on the pumpkin. Now, to be considered a line on the pumpkin, it had to go from the top all the way down to the bottom of the pumpkin. You'll notice that there are times where you'll see, and let me just get my pen here so I can show you, these little lines in between, like right here is one, and there's a faint one here, even some pieces here. Those we did not consider to be lines because they did not go all the way down the pumpkin. They just stayed, and they were just areas of growth that the pumpkin had made. So again, you want the students to count the number of lines on the pumpkin. Once you've counted the lines on the pumpkins, then the next piece is, of course, if you haven't had students do this already, you want to open the pumpkin up and let them see the inside. This is the best part of this activity right now because they're getting to see the gooey insides. The light yellow pumpkin that was on the right-hand side, for me, was extremely moist on the inside. It had a lot of water in it. And in fact, you can even see right here, see how wet this pumpkin is right here? This one was extremely wet. So you can also see the different seed pieces right here. You can see the seeds and how they're attached even up here to where I cut off the top of the pumpkin. So you can have the students count the seeds. Or what I did was I went ahead and dug out the seeds and I separated them into bags. And so we had a group that worked on one of the bags and another group that worked on the other bags. So here's another picture that I took just to show you the inside. Again, I think it's really important before you start scooping it out to let your kids make observations of what it looked like on the inside. Again, I've heard from several stories that for every line on the pumpkin there's a row of seeds. Well, that's really hard to tell because as you're looking at this picture right here, you can see that the seeds tend to jumble up into 3 areas within the pumpkin. And so it was really hard to see if those lines were actually connected directly to a line on the outside skin of the pumpkin. But again, you can see there are a ton of seeds in this pumpkin. And the kids, when we opened ours up in the classroom, they were super excited at this point, which I'm sure if you've done this with your kids before, you've experienced that. Then, of course, what we did is we had the students separate out the seeds. So I just gave them the bags. And this was where we actually used what we've been learning in math. I'm a real big believer that kids need to have a context for the skills that they're learning to do. And skip counting is a skill. So counting by 2s, by 5s, by 10s. We do it, I know, a lot of times in the classroom with random things. But again, the reason why we want to skip count is because it's efficient. And so what I tried to have the students figure out was what was the most efficient way to count. Was it counting by 2s, counting by 5s, counting by 10s? And of course, they had to figure out which way was most effective and which, and how we determine that is which group finished first. And believe it or not, the kids that counted by 10 were done relatively quickly. So again, here's the context for why we're learning to skip count. It's the real world experience of when am I going to have to use this math skill? Well, this is it. If we want to know the total number of seeds in a pumpkin, we've got to count them. And what's the most efficient way to count them. So at this point in the lesson series, you're now going to explain to your students about pumpkins. Now, if you've done the Engage and the Explore, that might take you 20 minutes. So on the next day, bring your kids back together, sit them down on the carpet, and this is where you want to introduce them to pumpkins. This might be where you bring in some great text in your classroom. There's some great children's literature out there on life cycles of a pumpkin and also on some different other things about pumpkins. But just so you know, pumpkins are fruits and they're members of the gourd family. The gourd family, what makes up the gourd family besides pumpkin are cucumbers, honeydew melons, cantaloupes, watermelons. The French explorer Cartier, when he was looking at the St. Lawrence region in North America, he found these things that he entitled them called gros melons. And he translated the name in English, which are pompions, and that has evolved into pumpkins. What a great way of showing kids just the changes in linguistics, vocabulary over time. So planting season typically for the pumpkin is the last week of May and the middle of June. Again, you don't want to plant too early because sometimes in May the temperature in North America where we grow these pumpkins, particularly in the south, is not warm enough yet for the little seedlings to grow. So we want to let it get a little bit warmer towards the end of May and the middle of June. So, if you're on the eastern seaboard, middle of June is probably going to be your best bet. Again, the explain portion, this is where you're getting the kids to learn about pumpkins. If you wanted to do the life cycle, you could certainly introduce that here as well. The extend portion of the lesson, this is where you're going to get the students really thinking and working like scientists. So up until this point, we've just done an activity. Students have made observations, they've learned a little bit of facts about the pumpkin, but we've not changed anything. Now we're going to look at the differences between our two pumpkins, and we're specifically going to look at the number of lines and how many seeds are in the pumpkin. So the variable that students are going to be manipulating have already been manipulated on the pumpkin. Okay, because we've picked up two pumpkins that have two different number of lines. So we're going to be asking kids the question, we want them to find out, does the number of lines of a pumpkin indicate how many seeds will be inside the pumpkin? We want to lead our kids to develop a hypothesis. So a hypothesis is different than a prediction. Hypothesis says if we look at one factor, there's a direct relationship to another factor. Whereas a prediction is just a future observation that we're going to make. It's a prediction of what we think is going to happen based off what we've learned. So we're going to have students make a hypothesis. And again, we want the students to say if the number of lines on a pumpkin indicates the number of seeds, then a pumpkin with more lines should have more seeds. And that's what we're actually testing. We are changing the number of lines between pumpkin A and pumpkin B, and then we're going to have the students count the number of seeds on the inside. So this is our testable, our hypothesis here, and that's the question we're testing. Does the number of lines on a pumpkin indicate how many seeds will be inside the pumpkin? So your data collection chart, your independent variable, what you are changing, what you are causing to change, is specifically the number of lines. So if you go back to my pumpkins, pumpkin A was the lighter one that was on the right-hand side, and pumpkin B was the darker pumpkin, taller pumpkin on the left-hand side. And this is what my students found in their pumpkin. They found with pumpkin A with 21 lines, only 701 seeds. With pumpkin B, they found that 26 lines, it had 805 seeds. How cool is that? Now at this point, we need some other data to verify it. This was just one trial, so we can't really say that the number of lines on a pumpkin will always indicate the number of seeds. But if we were to test a couple of more pumpkins, then we could come to a theory that we think the number of lines indicates the number of seeds on the inside. And in truth, number of lines, the color of the pumpkin, those all determine how long it's been on the vine. So I hope that you've enjoyed this, and I hope that you will have your students counting those numbers of the lines on the pumpkins and telling me how many seeds. Lastly, if you're looking for some more free materials, please subscribe to my YouTube channel and then email me the number of subscriber you were, and I'll send you a free center activity. You can email me at justsimplescience@gmail.com. I hope you enjoyed that activity and the experiment that came at the end. Just remember, teaching science doesn't have to be hard or expensive.